Hello and welcome to my YouTube channel. If you have not subscribed, please subscribe for me. Thank you very much. The formula for finding directional derivative. This is another way of solving the partial differential equation, first order partial differential equation. Sometimes in exams you'll be directed to use this method, okay? If you are not directed, then you can use any one of them. So you are going to go through all the methods, series of them. So we start with the directional derivative. The formula for finding the directional derivative is given as this. Okay, so this is the formula. In fact, this b and this a here are the coefficients of this and that. Okay, normally the b is the coefficient of u subscript y, and the a is the coefficient of what? U subscript x. So this is the general solution that is given. So all you need to do is to get the value of a and the value of b, then you substitute it here, then you get your general solution. That's all. So for this one, if I want to do it, very simple. This is ux plus uy equals 0. So our a will be 1, b will be 1. As I said, normally the a is for the u subscript x and the b is for u subscript y. So if you look at this one, our general solution now becomes f of, now b is 1, so we have x minus y. So therefore, u of x comma y is equals to f at x minus y. So that's our general solution. Simple like ABCD. I know by now some people are laughing. Yeah. For the second example, we have solved the PDE for u x minus 3uy equals 0, subject to the auxiliary condition, which is this. So I have already informed you that when the condition is given to you, it becomes a particular solution. You get a general solution, you substitute the condition, you get a particular solution. So let's see how you can go about it. Because you are using the directional derivative, you are going to use that one to solve. When we get to the other derivatives or the other method, you also use that. But for now, we are dealing with directional derivative. The directional derivative, you say the formula is giving us f at bx minus ay. So first, you need to be able to identify a and our b. So per this, a is the coefficient of this. So that is 4. Then b is what? Negative 3. Is that okay? So when I can have u to be equal to f at negative 3x minus 4y. Have you seen that? Good. Now we are to substitute the initial condition there. The initial condition that was given us, u of 0y is equals to y cubed. So this is our initial condition. It means that wherever you see x is 0, y is y, u is what? Y cubed. So let me put y cubed here. Y cubed is equals to f at, if I put 0 at the x position, this one goes to 0. So have 4y, because we say y is still y. So you put y there, is still y, not y squared. You are not multiplying, you are substituting it. You are replacing it. Because when you are playing a football match and we bring, let's say two players have the same name, you substitute one with the other. Two of them will not stand on the pitch playing at the same time. No. Okay, so now if you have something like this, please, I'm going to apply something. So just look at it critically. What you do here is that we are going to let P to represent this, okay, because of the nature of how it is looking like. This is assuming that I have f at y equals y cubed, then you can say that wherever we see f, you should put y cubed there. You see that? But this is negative 4y, so you need to do something to get a single number or a variable inside this, okay? So what you are going to do is that good. Here, what you are going to do is very simple. you are going to let, can use any variable, let p to be equals to negative 4y. So if you have something like this, what it means is that if you make y the subject, you are going to have y to be equals to, you're going to have y to be equals to negative p over 4. Is that okay? So now we have changed the function to p. So it means that here I'm going to have f at p is equals to, now when I come here, at first when it was negative 4y, it was y cube, but now it is p, but the y is now what, negative p over 4. So wherever I see y, I put negative p over 4 there. So I have negative p over 4, but remember it's power what, 3. So even if I replace or apply the cube on it, I have negative p cube over 64. 4 cube is 64, right? Okay. Now, you remember the question was not given to us in terms of p, but it was in terms of x and y. So this is what you are going to do. You will come back to this place. We are saying that f at p is equals to this. And here was f of negative 3y minus 4y. So the whole of this is what is in this bracket here. So you are going to replace this p by the whole of this. That is how it is done. That's why I was saying that it is a little bit confusing, but you need to understand it. I know a lot of you are confused, but that's how you go about it. After you substitute this one here and you get the p, you will come back to this place, okay, to replace it. Back the function here. So if I replace the p by this function, I'm going to have so wherever I see p, I'm going to replace it by this. So I'm going to have negative 3x minus 4y all cube over 64. Is that okay? But if I factorize this negative out, see that it will cancel this, so everything there will be positive. So let's see that one. F at negative 3x minus 4y will be equals to 3x plus 4y all cube over 64. So it tells you that, you remember, the idea was you just want to remove this f from there. Is that okay? This function, you want to remove the f from there. So remember u was equals to this, right? And now this is also equals to that. Therefore, u here will be equals to this. So we can say that u is equals to, u in terms of x and y is equals to 3x plus 4y cube all divided by 64. So this becomes our particular what, solution. In fact, this was our general solution. This one was our general solution. But we needed the particular solution, so they gave us how do you call it, initial condition, then we do the substitution. But I'm saying that when you get to this place, it's a little bit confusing. Let something to represent it, and that's why we did the make y the subject, meaning that when I come here, wherever I see y here, I'm going to replace, because now y is negative p over 4. So wherever I see y, that I replace by this, you get this. Then you go back to the general solution, which was f at negative 3x minus 4y. So you are just going to replace this p by negative 3x minus 4y. Mean that wherever you see p, you put the whole of this one there. And this becomes your particular solution. Is that okay? PS, particular solution. It sounds nice, yes. So, okay, now let's look at last one. Then you look for some and try them. Solve the equation 2ut plus 3ux equals 0, subject to the initial condition u of x 0 equals sin x. So this is the initial condition. You can pause the video and try after that. You watch it and see whether your answer is correct. So hi. First one, we know that u is equals, we are still using the directional derivative formula. Okay, bx minus ay. So our a, now here don't be confused. By the look of things, x is here and here is 0, means that the t is now representing the y. So our a will be 3. Then our b will be 2. Okay, good. Then we have u equals to f at 2x minus 3y. Even if it is interchanged, don't worry, this is a general solution. If somebody pick a to be 2, b to be 3, and you get 3x minus 2y, it's still the same, nothing will change. If you use when you get general solution like this, there's no problem with it. Don't worry. Now let's move on to the particular solution given. So here means y of x0 equals sine x. So what it means is that wherever I see x is x, or wherever I see, okay, here is in terms of t, so here will be t, and here too will be t. Wherever I see 0 is t. So if I put 0 here, this will go to 0, leaving f at 2x equals what? Sine x. So I'm going to have f at 2x equals to sine x. Okay, but because this place is 2x, I'm replacing x. You let p to be equals to 2x. You make x the side, you have p over what? 2. So now f at p is going to be sine. Wherever you see x here, you put what? P over 2 there. Is that okay? Now, after getting this, you come back to this place. Then replace the p by the whole of this. That's what I did first. So that I have f at 2x minus 3t equals to sine bracket open 2x minus 3t all divided by 2. So therefore, our u of xt will be now equals to sine of 2x minus 3t all divided by 2. So this becomes the general particular solution, and this becomes the general solution. Thank you very much for watching. Try to subscribe if you have not subscribed.